All right, and again, today we're going to be doing vocabulary stuff. We'll get to the math, we'll get to the applying this stuff. You're probably like, I learned this in junior high. Probably. But you know how many people have learned how to multiply in junior high, and then when I asked them what 4 times 8 is, they couldn't tell me? Like the 21-year-old at the store that couldn't split change for me. Gave him a $20 bill, the girl, for a thing I bought that was $19.33, and she wandered around looking for the calculator. I don't remember what I bought. Okay, this is kind of common sense, but your coordinate plane, and this just specifically says a number line, but you guys know a coordinate plane is just 2 number lines? We talked yesterday about the quadrants and how the signs, positive or negative, tell you what? Okay, so the direction, very important. We're going to have to apply that quite often in physics. You're probably thinking, I know what the origin is. I know that left is a negative, right is a positive. Just like to put it right here, just let someone punch it really hard. Probably was so hard. Okay. Anything up here new? Mr. Kramer, you're boring us, Mr. Kramer. Okay. So I think I said this earlier, but a coordinate axis is just 2 number lines. You've got 1D, 1 dimension, 2nd dimension. And I could add a 3rd dimension that would be going into the plane and out of the plane, and that's how you get your 3 dimensions when you're talking about area and volume. The 4th dimension, that's the spiritual dimension. You can't see that. But time. How do you describe time? If you were to give a definition for time, could you do it? What did you say? Wasted. That's fun. I just had dopamine flow through my brain. You never got the talk that I gave yesterday? Did you know that social media can produce the same drug that comes out of your brain as doing hard drugs? Dopamine is what gets secreted out of your brain when you do crack and all those things. It's the same thing that comes out of your brain when you get a like on Facebook, when you get a tweet, when you get a text from a friend. That's why when you're bored, what do? You send out 15 texts to people hoping they'll respond. Because you're addicted to it. Same thing with video games. You play video games all day long. You want to know why you play video games all day long? Because you're addicted to it. Not because you don't have anything better to do. Because you want to know what's better than video games? A lot of things.
Bread.
Like reading your Bible, just an overview. So yeah, we monitor when people can drink alcohol because of the addictive nature of alcohol. We monitor when you can smoke a cigarette because of the addictive nature of cigarettes. But we give cell phones to our children at age 4. Makes a whole lot of sense, doesn't it? Got my first smartphone at 29, guys. My poor kids. They're not going to see the phone until they're 32. Okay? So non-physical continuum that orders a sequence of events. So, yes. Can you rip time? That's a deep question. You're asking me to go into the areas of depth that you may not want the answer to. What? You two kids? That's debated. I don't know. I haven't researched it enough to give you an answer that would be more than just a guess. Unfortunately. Okay, you don't have to. Okay, yeah. You can put the first bullet in. You don't have to put the second 2 bullets in. This is just kind of some added stuff that I think most of you guys probably understand. But time started when God created it, because before God created time, you had eternity, which, can you put a timetable on that? Not really, right? Anyway. Okay. Bible says, before time, I am. Alright, so I'm going to kind of give you, this is just kind of a foundation for what you're going to see with the Greek symbol delta, which will come on the next slide. Okay, so time is an ongoing sequence that orders events. So anything we study in physics is going to be done in a certain time frame or time span. Okay? With us, Emma? You already wrote that all down? You're not going to?
No, I'm going
Okay. Okay. Well, it looked like you were daydreaming, so I was just trying to get you on task. And so we have a way to abbreviate the initial time. Then we have a way to abbreviate the final time, and that's going to take care of the whole time span. Delta is the Greek. What do you mean? We're getting into being able to use the Greek symbol delta and what it means, and then see some equations with that as we progress. Probably a little bit. So you learned what delta was in 8th grade? You were homeschooled, weren't you? That makes sense. Homeschoolers can actually read and write and multiply.
Wow.
So we're watching our one of the neighbor boys. His parents are out of the country on vacation, so he's spending the night with us, and he's like totally into Rubik's cubes. And he's got like, no joke, 50 Rubik's cubes of all kinds of shapes and sizes, and he knows the algorithms of all the Rubik's cubes. And so he just goes like this, and it's done. Fastest he's done a Rubik's cube is like 20 some seconds.
How old is it?
He's 15. He's your age.
Oh, okay. I thought you were like, yeah.
No. And it's pretty cool. He's got like a 10 by 10 Rubik's Cube.
Oh my.
He's got ones that are shaped like diamonds and triangles, and he can do it all. It's pretty crazy. I was messing with it. I was pretty intrigued last night, just playing with the Rubik's Cubes. I was able to get one side of a what was it, a hexagon? There was a hexagon one that I was doing.
Have you seen the
Good
one?
job, Kramer.
Well, he said he's talking about dimensions, so I thought about that. He said that there's a 33 by 33 one that someone made, and it's like $190,000. It's crazy. Okay, so anyways, this next slide, we'll put it all together here. Yeah, that's kind of a goofy way. I'm going to rewrite the equation. You're going to want to write the equation in here. Here is the equation for time span. Delta t, the final time minus the initial time, will give you your change in time. So you're going to want to write here that this Greek symbol delta means change in. I think that's, it doesn't say that exact word, so you can go ahead and write that in as well. Other than Mari, anybody seen the Greek symbol delta before? Is it other than Mari? Did you know it meant changing? You've seen the Greek symbol before? Yeah, your dad's a math teacher, you better. Yeah, I want you to write, you don't have to write this bottom part, which, that's kind of, I don't know why that's even there. I want you to write that. So another way of saying change in, when I talk about the Greek symbol delta, it also means difference between or difference in. So delta close would be the difference between your initial close and your final close. You can put that on anything. Okay, so let's say I started my stopwatch and I started moving at time 10 seconds. And then I stopped my motion at time 50 seconds. What was the time interval or time span that my motion was under? 40 seconds. Okay? So we're laying the foundation for being able to take this and applying it to velocity, acceleration, and things like that. Yep. All right. Last two vocab words. These are probably the most two vocab words, maybe of the next 3 chapters. Or maybe put like, a star by the next couple vocab words, because they aren't going away when we get past this chapter. It's kind of like chemistry. Kind of like chemistry builds on itself. Who would have thought? Physics builds on itself too. You actually have to know what you learned a second ago, not just put it in your short-term memory and throw it away when you're done with it. What happened? Absolutely. That's
So when the length vector is like, I've got both direction and magnitude.
yep. When I introduce vectors in physics, I always play that little clip where he's like, vector committing crimes with both magnitude and direction. Whatever.
Fix your face.
Oh yeah, piranha gun. Have you ever seen one? No, we haven't, because I invented it. Okay, yes, our next vocab word is vector. Okay, so, and this is important because most of the time in math, this is what you do. You just focus on numbers, you add them, you subtract them, you multiply them, you divide them. Okay? It's a measurement that has a magnitude but no direction. Which you can imagine when you're studying motion, if I say you traveled 13 meters and that's all I said, isn't that missing a lot of information? Well, 13 meters. This way, this way, this way, this way, this way, this way, this way. Which way? Problem, right? So you don't have to put in the example here. Just put in the written stuff here. So can you ever have a number less than 0 when you're talking about a scalar quantity? No. And we will talk about our first scalar and vector quantity tomorrow, which is the difference between distance and displacement. Have the same unit, but they mean different things. Okay? We have no direction. We said, what was the number one indicator that told us direction in the context of math? What did I say yesterday? What tells you direction in math? The symbols, okay, what more specifically what? Positive and negative. Okay, a positive tells you direction. A negative tells you direction. I showed you the number lines, and I said if you're going in the positive direction here, which way would you be going? Okay, you could be either going north or you could be going east or somewhere in between. In fact, in physics, we throw an angle in it and we say we're traveling at 25 meters per second at 32 degrees east of south. Okay? We'll get to that as you guys go in. So, vector, committing crimes with both.
Oh, yeah.
If we have time. So notice the quantity or the amount is exactly the same from this example and what example? Isn't there some similarities between this example and your scalar example? They're very similar. What's the only difference? Yes. And that ENE, anyone have any idea what that means? East of northeast. Which, it's way easier to just give an angle than to say east of northeast, because even that could be within a 45-degree angle. Two-dimensional motion is a little bit more difficult. Now, in physics, in this class, we're only going to do one-dimensional motion, so you won't have to worry about angles. You guys, you don't know probably much about angles up to this point. Okay, now let me kind of show you what does magnitude represent? Because both vector and scalar have the word magnitude in it. So what is a magnitude? An amount. Okay, so what up here would be a magnitude? Yes. This is a what? It is an amount. That's what a magnitude is. So if I ask you what is the magnitude of your what is the magnitude of you walking from point A to point B, you would be able to give me a number. You wouldn't have to give me a direction. Okay? For it to be a vector quantity, it not only has a magnitude, which is what the scalar quantity has and only has, but it also needs to tell you what direction you are going. Now, even this direction is pretty subjective, isn't it? Which way is forward? Depends, right? So it says the magnitude part of a vector is called scalar. Does that confuse you? Maybe I'll let you just think about it for a second and then see. Someone want to explain what this is trying to get at? Any ideas? I maybe could word it a different way, but. So what's the definition of a scalar quantity? Okay. Has a magnitude, but no direction. What's the definition of a vector? Magnitude and direction. So it's saying the magnitude part of a vector is scalar. So what that, if I were to reword that, I would say, if you take away the direction of a vector quantity, what do you have? Scalar. That make sense?
Yeah.
Because we're going to talk about distance and displacement tomorrow. Distance is a scalar quantity, which means it only tells you the amount. Displacement not only tells you the amount, but tells you the direction you're headed. Fine? I think this is the last slide. You know, let me see. Okay, put this in. This should be our last slide. You guys know why a vector goes like this? Because he's representing an arrow. Because a vector in physics is usually represented by an arrow. And I think he even mentions it at some point in the movie. The big thing that I want you to get out of this is the arrow's length represents what? And the direction it's pointing represents the direction. So if I had two vectors, I had this vector and I had this vector, what could you tell me? While we pack it up, I had this vector and this vector, what could you tell me? Anything you can tell me about these. Talk about these two vectors. They're both going the same direction, but one appears to be twice the magnitude as the other. So if I said this was 20 meters, what do you think this is? 10 meters. All right, Millie.
We even saw it close.